So this is recording at the moment. I can't remember how when you look at this on YouTube, this thing will be turned upside down. I can't remember, was it Control Alt and down arrow or something will turn the screen for you, and then Control Alt and up arrow will turn it back to the way it originally was. I think. I can't remember. So while we're waiting for the rest to come in, I know we're ahead of schedule. Can I just ask you about the homework then, please? Any questions on homework? Question? Go on. I'm sorry, I can't. There's people coming in behind, so I can't hear. Give us the numbers. 5, part 2. Is that it? Did I hit it bang on? 5, part 2. Okay. Question? That's the cos 2 theta one. Yeah? The cos 2 theta is equal to 0.5. I can't hear, I'm sorry. I still can't, I'm sorry now, I mean that sounds terrible, but I can't. Shout it. Pretend you're a Donald Trump supporter, go on. 200 and? Good, now we get to 244, go on. Question 5, right, I have you now. Question 5, that's the one with the 2 triangles. Yeah, okay. I'm sorry now, but I genuinely couldn't hear. It's very hard with the mask. So this is 48 degrees. I'm not putting in the degrees because they end up looking like zeros. This is 100. This is 80. And I'll just label these A, B, D, C. Now, and we're asked to find the length of AC and the length of AD. The length of AC and the length of AD. I don't like the way they phrase that. Anyway, how many triangles are there in front of me? How many triangles? 1, 2, 3. Many? Well, do you recognize that there's 3 triangles there? There's 2 small ones and a big one. Be aware of that. Looking at that picture, 2 small ones and a big one. The approach to this question, I'm looking for 3 bits of information. In the one on the right, I have really only 2 bits of information. I can concoct one. I know that this is 110. I know that's 110 from the 180 all the way around. So looking at the triangle on the right, there are only 2 bits of information, and I'm snookered on that one. On the triangle on the left, I can see I have 3 bits of information. On the triangle on the left, I have 3 bits of information. Actually, yeah, what did they want me to work out? AC and AD, 48. I'm just looking at it. I think they've asked that the wrong way around, but however. So, we'll use the first rule to work out, I can work out this angle here. I can work out this angle here if I want anyway, but I can work out this missing side here, which is AD. So I can go, I do my crisscross here now. Look, I put it in because it helps me to work with it. So I'm going to say 100 over the sine of 70 is equal to x over the sine of 48. How many of you did that out? I want to get my book. I just want to get my book to get that now. How many of you got that out? Only a few of you. So tell me, the people who didn't get it out. Also everybody did, but I just get this here. So it's question 7, exercise 7.8. 7.8. And what you say what was? Number 5, question number 5. So this works out that AD turns out to be 79. So X turns out to be 79. How many of you got that? Okay, AD turns out to be 79. Right, now, what about getting AC? We haven't actually done the AC bit yet, I'm terribly sorry. Some of you who did this from last year, did you use the cosine rule? I'm sorry, I didn't realize that hadn't done the cosine rule by the time we got to there. Oh, there is the cosine rule. I'm terribly sorry now for some of you scratching your heads last night for half an hour trying to figure that out. You see, we now have 3 bits of information about the triangle on the right-hand side. But there's no crisscross. Look. There's no crisscross. Now, can I just say this, because I've often seen this in action, that people would go 70 and 48 is 118, and whatever angle that is there then, that this is the same here. That's not true. Unless you can prove something is absolutely true, don't assume anything. You know, you can't assume that those 2 angles are the same, those 2, because they're beside each other or anything like that. So, unfortunately, we're kind of snookered with that. So, I'm sorry, I didn't really, actually, when I looked at that page yesterday, I thought it only did the sine rule on that page. So, how many people didn't get 79 on that? Everybody did. Jeez, that's great. Okay, any other questions from the homework? Rory? 3 part 1. Yeah, no, I'm sorry. You see, it says use the cosine rule. I'm really sorry. When I looked at that exercise yesterday, I thought it was only sine rule. So we'll be doing it before the day is out. Anything else, anybody? I'm sorry now about that. I didn't spot that. The exam question. How about, just call it out to me there, Claire. I remember it. The cos of what? 2017, wasn't it? 18. 2018. The cos of 2x at home, wasn't it? The cos of 2x is equal to minus root 3 over 2. Yeah? That is. So, same crack as before. And we've got to say what 0x, we're dealing in degrees anyway, which makes it slightly bit easier because I know people like to work with degrees. So where is cos negative? Cos is negative here and here. There goes my red dots. So we're up and running. Everything okay? So we then say my reference angle is the inverse cosine of root 3 over 2, which is 30 degrees, I think, isn't it? So that means my real angles are, so 2x is equal to 150, and because I know I'm dealing with 2x's, I'm going automatically into my n360. You know, if it was just an x and those that limit of 0 to 360, then I would just, I wouldn't have bothered doing the general form. And the other one is 210 plus n360. So then x is equal to 75 plus n times 180, and x is equal to 105 plus n times 180. So then let n, I'm writing in green, n is equal to 0, so x is equal to just 75, and x is equal to 105. I'll just do something else in my head there. And when n is 1, I'm getting x equals 255, and I'm getting x equal to 19185. How many of you got that? You got that? Okay. So x is between 0 and 360. So we have 1, 2, 3, 4. Is that all there is to it? When n is 2, sure, we're gone when n is 2. How many of you got that out? That's very good. I don't know how many marks was going for that, but I'd say it was significant enough now. Doesn't give the marking scheme. There's exactly what I'm talking about, that question there. That is exactly what I'm talking about when I say method maths. You learn how to do that, and you don't leave it until you, not that particular one, you don't leave it until you know how to do them. That sheet that I gave you out this morning, there's a whole stack of those in them. You need to be able to do every one of those on that sheet. Tomorrow I'll be giving you another one. Now, I don't say you have to do every one of them. I just mean you need to be able to do every one of them. So when you scan down a few of them there, am I able? It's the same process all the time. There's method maths at its best. There's where you pick up your 15 marks, 15 here, 15 there, just like Joe Biden in the election, picking up a few here and a few there and a few there, and eventually build up a total. Same crack here. Don't worry at this stage of the year about the heavy stuff. Worry about the light stuff. Worry about that kind of stuff. If you're not able to do that, you will be dragged down somewhere else. Not only will you be dragged down on question 4, but somewhere out again on question 6 or question 7, you'll be dragged down again because you didn't know how to do that. You have learned the equivalent of the minus b here on that. That's what you've learned. So really, really, really important. Anybody else got anything? $240. Question number 6. Which part are you talking about now? Part 6 and question 6? I'm sorry, question 2, part 6, but we were to use 2x, wasn't that right? So this is the minus 1 crack. That's the problem with this one. The cos of 2x plus 1 is equal to 0. So therefore, we would say, again, get the trigonometry bit on its own. Now, can I just say this, because it's obvious that you don't do this, but some people will. You can't divide across by 2 there and get cos x equals minus a half. Be aware, you cannot get inside that. You can never get inside that, except with the help of a formula that we're going to learn about in a while, how to open up something like that. So the cos of 2x is equal to minus 1. How do I get inside that 2x? I can't, unless I apply another formula. There's no messing here with 2's and dividing across by 2 or anything like that. You can't do that. Nor can you do this. You know, the cos of 2x, you can't multiply in there and get the cos of 4x. Forget about that. That's not on the agenda at all. So the cos of 2x is equal to minus 1. Because it's those one-y ones, 1's and minus 1's and all that, I know I do the unit circle. That's what I'm using on this one. So this is 1, 0, cos sine, here we go, cos sine, minus 1, 0. And this is 0 minus 1. So I now know 180 degrees is my answer. So there's only one answer to this one, between 0 and 360. So I will be saying my actual answer is 2x is equal to 180. Now, did I give you limits on this? I did. 2x is equal to 80 plus n times 360 if I want. So x is equal to 90 plus n times 180. Right? So when n is equal to 0, I'm getting 90. And when n is equal to 1, I'm getting 270. So there we go then. Just double check on that now. Whatever my calculator is. Yeah, it's going to work anyway, I know it is. Yeah, we're getting a minus 1. So there we are. You all right on that? Is that what you got? You forgot the n360, I bet, did you? When you have the two x's, remember, you need to go, because look, even if you put in the n360 and it was wrong to put it in, it will show up anyway, because you won't be including the extra answers that you were getting. You know, if they had said to me there that x is between 0 and 180, I would still have done this because I see 2x. But when I get to here, then I realize, oh Lord, I won't be using that answer. You know, so you'll know that. So putting in the n360 is never incorrect, because you'll be picking the answers in the end. Which ones are the ones that I can allow, or which ones can't I? How many of you got that out? That's the bit I was telling about that I was thinking about yesterday coming in the car, about the 1's and the minus 1's. They're unusual ones. So you have to concern yourself with those. Anything else? Right. I'm going to work with the other part of the triangle now, which is the only time that you can't use the crisscross rule. There is another rule. It's called the cosine rule. And this is the cosine rule. I'll put the A here. A, B, C, C. And there it is. A squared is equal to B squared plus C squared minus twice BC cos A. A squared is equal to B squared plus C squared minus twice BC cos A. Cosine rule. I'll show you the workings of it now in a tick. How many have seen this before? Few of you, yeah. Now, the big news about this, or the big thing, the working of this, certainly, look, they're opposites to each other. So the beginning and the end of the formula are opposites to each other. You can call whichever side you like A, and whichever side you like B, and whichever side you like C. It's Pythagoras' theorem with a little bit of an extension onto it. A squared is equal to b squared plus c squared. But then there's an extra tail, minus twice bc cos a. And the only time you will use this, you will recognize when to use this, because it will look like this. There. There's no crisscross. So I will use the crisscross wherever I possibly can. The only time I can't use a crisscross, well, there's two times. There's one. Basically speaking, it's two sides and the angle in between the two sides. Any two sides of a triangle with the angle in between. Now, that then becomes A in my formula. So the one opposite the angle I'm going to use is always the A. So whatever angle I'm going to use in my formula, the beginning of my formula will be the opposite side to that. So in this particular example here, it will be A squared is equal to 8 squared plus 9 squared minus twice 8 by 9. Look at that. It's a lovely formula by the cos of 30, and you just plug that into your calculator. So A squared is equal to, oh yeah, I want to show you something now. (16 by 9 is 1, yeah. Now, the maths of this is quite easy. I mean, you just work this out, you type it into your calculator. But what I have seen down the years, people making one or two little mistakes on this. You can't add the 64 and the 81 and take 45 from it, 145 from it. I've seen people add these two together and subtract that without messing with this at all. You know, and ending up, it sounds that it doesn't happen. It sounds like that couldn't happen, but I've seen it happen. That's why I'm reminding you about it. But because you have a calculator now, I'm probably thinking of the days before calculators. I'm getting an answer here of A squared equals 19.42. Because you have a calculator, then you'll be reasonably okay on this, or should be. So I'm getting A to be 4.4. And that's it. So it's a lovely, useful formula. And look how you recognize now how to use it. It'll be all stuck in the one corner. So the angle will be in between the two sides. And that's how you recognize when to use it. Other than that, we'll use crisscross. And that saves me having to use sine, cos, tan, all that crack that we used to use at junior cert. We don't need it anymore now. Now, we do need sine, cos, and tan for working out, when I want to fill out triangles and stuff, but not for actually working out things like ladders leaning against walls and stuff. I really don't need those anymore. Genuinely, I don't. So let me show you now a couple of variations of it. That's it. That's all there is to it. So you might see them all over the place. Like you might see the 30 degrees there. Just don't, I'm not going to work these out. The one opposite is A. You can just choose whichever one is A. And off you go. It doesn't matter which one is B and C because you're doing the same thing to both. So it doesn't matter. That still is going to read A squared is equal to 8 squared plus 9 squared minus twice 8 by 9 by the cos of 30. So it's a lovely rattle-off formula. No matter where they are, no matter what the angle is, you'll recognize when to use it. There we go again. In this case, this will be A. And off you go again. 9, 40 degrees, 6. In this case, I don't need to use it at all because I can use the crisscross rule. So I don't need to use it in all cases. And I'm just going to, just one or two messing here just to show you a few of these. If I had this 8, 30, I can see straight away because of that written down, I'm going to be using the crisscross rule here. Now, do you see this? Oh, not that. Supposing they said work out that. Now, I know it's the crisscross rule because I'm using crisscross. But it's this way I want to go. But you can see 40 and 30 is 70. So I actually have 110 there. So yes, I can use the crisscross. I can't go this way, but I can go the other way. So sometimes the crisscross won't be immediate in front of you. Let me just show you again now. 40 degrees. Why am I writing degrees? 9, 10. And I want that side there. Now look at that. I want that missing side there. And you're thinking, yeah, crisscross will work here. But when I do crisscross, all I'm going to work out is that angle there. But sure, that's a great help because because once I get that angle, then I know this one up here, and then I do a second crisscross. Do you see what I'm talking about? It won't always be immediate that the crisscross rule will work for you perfectly every time. You might have to do a little bit of work to get where you're going. But once I look down at the triangle, when I open the page and I look down at the triangle, what I want to see is 3 pieces of information. And I know if you give me any triangle with 3 pieces of information, I can do the question either by crisscross or by a squared is equal to b squared. So look at that last one again now. If I gave you that and 9 and 10, and I want to work out this side here, straight away I'm doing my crisscross and I can see what I get. I get that. Now how does that help? Remember, I've said this. If I have 3 pieces of information, then I can work out everything else about the triangle. So I am fully confident, even though it looks like I'm kind of caught, because I see the 3 pieces, I know I can work out the 3 angles and the 3 sides if I so choose. So even though I might find myself going around in a roundabout way of getting there, I will eventually get there once I see the 3 pieces of information. So although I have to do this first, but once I get that, I get this, and once I get that, off I go again. And the only other one, just to show you, no, it's not the only other one. There, I realize I can't do crisscross, but I have the 3 bits of information again. Now I'm going to get you to do a couple of these in a second. I just want to show you one more. The only other time, there are 2 pictures to use the cosine rule. This is one picture. And all you have to say to yourself now, you know every bit as much about trigonometry and triangles now as I do. In the last 20 minutes, you've now picked up, you know every bit as much about triangles as I do. So there's absolutely no reason that you can't solve every triangle that's ever put in front of you. I don't use any other tricks other than the 2 formulas. That's all I use. So it's all about you practicing now and getting a bit of confidence that no matter what's put in front of you, if I see 3 bits, it's done. The question is done if I see the 3 bits. Sometimes you'll have to figure out what the 3rd bit is. Like we met one this morning now with this little thing. And how many of you didn't realize, oh, that's 110? You know, they're the little things that you'll have to, with practice, that you spot. You know, if they told you that was an isosceles triangle, to realize, okay, if that's 70, then that must be 70. And if that's 70 and 70, this must be 40. You know, so there will be little bits that you'll have to pick up along the way. But that happens with practice, nothing, only practice. Anyway, the other bit that I wanted to show you, and then off you go, you're going to try a few of these, is this. This time there's no angles, but there are 3 bits of information. So I'm quite comfortable to say, yes, there's 3 bits of information here. I should be able to work this out nice and handy. I should be able to work this out. So I don't know what they're going to ask me. Let's say they ask me, what's that angle there? I know it's definitely not the crisscross rule. Straight up, no crisscross in this. So I know it has to be the cosine rule. So I'm just going to straight down. A squared is equal to b squared plus c squared minus twice bc cos. Whoa, cos, I'm going to call that x. It's cos A anyway, that's what it is. So I'm interested in this angle. So this must be A. So remember, the angle you're interested in and the 2 ends of the formula are the 2 bits on the opposites to each other on the diagram. So this particular formula, I'll call this x, will run like this. 8 squared is equal to 10 squared plus 15 squared minus twice 10 by 15 by the cosine of A. That's what that formula runs like. The one opposite the angle you're interested in is always going to be A. And then if we call the angle you're interested in A, then the other side is also A. So that's 8 squared. So that then is 64 equals 100 plus 225 minus 300 cosine A. So 64 equals 100 plus 225 minus 300, I hope that's right. 30 by 10 it is. So I'm going to do a bit of calculating here now. 64 take 100 take 225. So I'm getting minus 261 is equal to minus 300 cosine A. Again, being careful that I can't subtract the 300 from these 2 numbers here. That's the mistake that I was telling you about earlier on. So now we have this. Notice that we're getting an answer less than 1. We have to. All cosines are always less than 1. So I get this 87, which is 0.87, is equal to the cosine of A. So 0.88 is equal to the cosine of A. So inverse cosine of 0.88 is 28.36 degrees. Okay. And there we go. So it's a lovely, lovely question. Just see this bit now, the last bit. That's the bit that you've been learning the last couple of days. You don't even bat an eyelid on it. Just say, yeah, solve this equation. Just solve a trigonometric equation. That's all. This is, by the time I get to here, this is just an ordinary maths equation. And there's no reason that we can't solve an ordinary maths equation. Just a matter of gathering all the numbers, isolating the unknown on its own. I worked my way down until I isolated the unknown on its own. And then did the last little step. So a lovely question. So I'll just get you to do one right now. Sure, you might as well do question 5 from last night, page 244. You can finish it on then. Those of you who have it done, you can just relax for a few minutes. You can find another one if you want to try. Maybe go over to number 9. Number 9 looks a nice one. You'll be doing it tonight, so you might as well get a head start on it. Those of you who had that done, number 9. From here now, I'll just take this up here. The sine of x is 0.8549. So x is equal to the inverse sine of 0.8549, which turns out to be, if I round it off, turns out to be 59 degrees. I'll let you get as far as there first now. Right. There's a small bit of a problem with this. Is because it's inverse sine I'm doing, and we just learned all week about having to do this crack with it. If I'm working backwards. So in actual fact, one of the angles could be there or one could be there. In actual fact, it could also be 121 degrees. Now, inverse cosine doesn't present us with that problem with triangles. You know, if I'm doing the cosine rule, inverse cosine, because the other positive one is down here somewhere, you know, so it's beyond the 180. But there is a problem when I'm doing inverse sines, that I could get 2 possible answers. And because this is 48 degrees, normally, when you would add this to this, you'd be beyond the 180 and you say, sure, it can't be that. But in this case, I'm not beyond the 180. So in actual fact, this angle in here could be 59 or it could be 121. And then in that case, the angle up on top, and again, I'm taking it from here, angle 2, it could be 11 degrees, no, what's the first one? It could be 73 degrees. I'm just taking it out of the book here, that's why I'm just looking it up, or 11. So you actually have to work with 2 separate triangles then from there on in. So you have to work out, if I redraw this now, it's going to look like this for one set of information, 48, 17.6, 15.3, 59, and 73. and the other triangle is 48, 15.3, 17.6, 121 and 11. And you have got to work out the missing side then based on each of those. You've got to work out the miss. It's known as the ambiguous case. That's what it's known as, the ambiguous case, where there could be two possible scenarios. Geez, there was one a couple of years ago in the Leaving Cert, and I think they didn't mean it. It happened in the actual Leaving Cert question. The examiners didn't mean what happened, and you ended up, I think you could have ended up with 3 different diagrams, and they were accepting all, whichever one people had interpreted the question as, they were accepting whichever one. But it was a right mess that they did. But we'll be meeting it in our own time. So just be aware, when you're dealing with triangles, if you're doing inverse sine, make sure that you come up with both answers. Now, invariably, more often than not, when you work out the 121 and you add it to the other angle you've been given, it'll be beyond the 180, so you can scratch off that. Another thing is, if they give you a diagram, like really based on the diagram I've drawn, 59 is probably the right one because 59 is an acute angle. You'll nearly tell by the way they give you the diagram as to what the answer is, you know. So just be aware, it doesn't happen for inverse cosine, because if you have inverse cosine equals cosine of x is equal to a half, if you do inverse cosine, one of them is going to be 30, but the other one will be 330 because of where the positive cosines are. The positive cosines are down below in the 4th quadrant. So 1st quadrant, 2nd quadrant, 3rd quadrant, 4th quadrant. So it's the bottom right. Okay. So that's, by the way, is the worked example on 725 in your book. So remember, if you're ever doing inverse sines on those triangles, be very aware of what's going on. And it's very easy, like it only works really if one of the angles that you're given is usually less than 50 or 60. Then you probably, like if this angle here, 48, was in the 70s or 80s, then the chances are it won't be the ambiguous case. So that's all I'm saying, just be aware. I don't think I've ever seen it really on an exam, unless by accident. Just want to give you a look at this. No, get rid of that. Now, if I want to work out, there's a right angle triangle. If I want to work out x there, we would always have said the sine of 30 is equal to 5 over x, and then off I go. Junior cert stuff. Sine of 30 equals 5 over x. It should be no issue. I wouldn't even bat an eyelid on that. The sine of 30 is the opposite over the hypotenuse. The sine of 30 is equal to 5 over x. Believe it or not, I can use the crisscross rule. So I can just go, look, this and this. So I can just simply go 5 over the sine of 30 is equal to x over the sine of 90. So I don't need sine, cos and tan anymore. I can do that sort of stuff, no bother. The good news is the sine of 90 is 1, which is lovely. The sine of 90 is 1. So it just simply becomes 5 over sine 30 equals x. So just be aware of that you don't have to panic and don't forget Pythagoras' theorem hangs around in the background here the whole time. So if you had something like that, 8 and 5, and I want the missing side here. Now obviously I would use Pythagoras' theorem. There is no question that I wouldn't use Pythagoras' theorem. But for whatever strange reason, let's say you don't recognize Pythagoras or you don't remember, once I see 3 bits of information, I know I can fill out whatever I need to know. So right now, right immediately, I can do the crisscross rule there, and I can work out that angle. Then I can work out the blue angle above, and then finally I can do another crisscross again. So you will get there, even if you don't spot Pythagoras' theorem. You can use these rules, these 2 rules that we've learned in the last 2 days, to go messing with stuff like that. Okay, so what you need now is lots and lots and lots of practice on using these triangles and stuff like that. And there are some nice questions. Don't forget the old geometry rules that you know. If that's an isosceles triangle, if they tell you, that's how they'll tell you, then that's the same as that there. If it's an equilateral triangle, then they're telling you that they're 60 each. If they mention something like this, something like that, and they're parallel, then it means that this angle here is the same. So you might have an angle, they might tell you that that's 50, but in a roundabout way they're telling you that that's 50. So using the parallel, remember the Z's? Remember? The parallel lines. And the same at this side. This angle here would be the same as that one there. So be aware of that idea when you're doing something like that. Just geometry. It's only with practice inside an exam or inside a question that you'll find it. Here's something else. There's a port, P. Now watch this one. A ship sails at 30 degrees north of east. Oh, here, what's that? A ship sails 30 degrees north of east. Where do I put my 30 degrees? So here's my cardinal points: north, south, west, east. Some people say that that's where the word news came from. North, east, west, south gives you information about everywhere. North, east, west, south, that's the news. Anyway, be very careful here as to how we fill in the angle. So you're told a story in the question. A ship sails at 20 meters per second in a direction 30 degrees north of east. Now, it reads it exactly as it says. It goes 30 degrees north of east. There's east. There's east. So this ship goes 30 degrees to the north of it. So there's where the 30 degrees goes. And they might tell you the ship sails for 10 seconds. So it's going at 20 meters per second for 10 seconds, then that's 200 meters. You know, so they won't necessarily line it up for you. So 10 meters per second for 10 seconds or for 20 seconds. That means it has traveled 200 meters by then. So look at that question now, 30 degrees north of east. So it's not east, it's north of it, so it's a bit up a bit. That, look at how else this could be phrased. It could be phrased like this: east 30 degrees north. So the ship goes east, but it goes 30 degrees to the north of it. You see where the 30 degrees is then. So the ship goes east, but then it goes 30 degrees to the north. East 30 degrees north. That's how that's written. East 30 degrees north. The same question could be this. A ship goes 60 degrees east of north. 60 degrees east of north. There's north. We're going 60 degrees east of it. So look where the 6, which is still 30 inside then. So look at how that's phrased. That'll take a little bit of practice if you're not sure of it. Applied maths people are doing this easy, but it takes a bit of practice on these to be truthful. Anyone in the Scouts probably have no problem with this either. Now, our ship then turns above. The ship above turns, and the direction it goes. So if it turns, what you always do if it turns is put in new cardinal points again. And this time the ship goes 30 degrees south of east. So let you put in where that ship goes now. Where does that 30 degrees go? This ship goes 30 degrees south of east. So draw in that. Where do you think that would be? The ship is after turning and it goes in a direction 30 degrees south of east. So that means it's heading off in this direction. Ship is after turning. Remember, there's our east, there's our south. So it goes 30 degrees south of east. The big question I have is where the hell do I put the 30? So it's 30 degrees south of east. Well, there's east, so it goes 30 degrees to the south, so that's there. Would that be fair enough? Now that means automatically that this must be 60 because the whole thing is 90. Watch me adding in the triangles here now, or the angles. If that's 30 there down here, the bottom left, then this must be 30 up here. So this must be 60 in here. So now I have the angle inside as 120. See how I had to build that up now? We'll be practicing those. I mean, this is not, I'm just killing a few minutes here while you're waiting for the last 5 minutes of class to finish. We'll be back to these. But just to see how sometimes the information about the angles won't be waving at you, you'll have to figure it out for yourself. They gave me an angle actually outside the triangle, but I was able to wangle my way into the inside. Oh, jeez, I forgot to tell you. Because a lot of you missed a lot last year, there was a lockdown, and I did hint at this way back, that we would be doing class. And I discussed it with John yesterday about an extra class. It will be on a Sunday. It will be a Zoom class. I won't, in previous years I brought people into school. I won't be bringing you into Sunday. I will be doing a Zoom class. I will be doing it mid-mornings to allow you a few hours in the scratcher on Sunday morning. So I will be doing a Zoom class. I will be starting with logs. Now I might only do it every second Sunday, depending on, I might do an hour and a half on a Sunday kind of thing. But I will be starting on logs, and I will be starting this week. It's at 12 o'clock. 12 o'clock. Zoom. I will send you a link through Google Classroom. And the reason for it, I don't want to be doing this. I certainly on a Sunday, I don't want to be doing this. You certainly don't want to be doing it on a Sunday. I'm doing it because I don't want to find, come next April or May, that we're really in trouble because of last year. I'm a little bit concerned about last year, that you didn't finish an awful lot of bits and pieces. So I will be doing logs. The thing about it is, it will be done and out of the way. So I will be starting this Sunday. I'll tell you more about it tomorrow, but you can just think about that. I mean, I know some of you know it will be uncomfortable, but I will record it. But really, you need to be there to be truthful. All right, I'll see you tomorrow.